Okay, this is the second part of the Gaussian elimination unit. We have to deal with systems of equations that don't have a unique solution, and we call it the general solution. So this is we'll just call it the general solution. And for example, if we don't have a unique, for example, like lines, like graphing lines, y equals 3x plus 5. There's not one solution, there's a set of points. And so the idea is we call all the solutions the general solution. Now what we're going to do is, this is our first time we're going to see the introduction of something called the parameter t for time. So the idea is y no longer depends on x, but your position, xy, depends on time. So after 1 second, where are you? After 2 seconds, where are you? We're going to get to that in a couple of units. But for now, for example, if I say 2x plus 3 equals 2x plus 3y equals 12, I want a general solution. So what we're going to do is introduce the parameter t, which is going to be an integer. Well, it could be a real number, but it could be a real number. Actually, it could be any no, it could be any number. We're going to introduce t, but I want you to start kind of getting in your head as it's time. 1 second, 2 second, 3 second. So, yeah, so you're going to let x equal t, and then solve for y. And so we have 2t plus 3y equals 12. 3y equals 3 minus 2t, and then y equals 4 minus 2/3 t. And so we're going to say the general solution, and we're going to write it in this form, is t 4 minus 2/3 t. You might see it like that, or you might see it like t comma 4 minus 2/3 t. So depending on the t, that tells us our location. Something interesting. So, for example, try this one on your own. Find the general solution of the equation 5x minus 10y equals 20. Same idea. So why don't you think about that a walk away? Same it. So we're gonna let x equal t, and therefore 5t minus 10y equals 20, negative 10y equals 20 minus 5t, and we get y equals 1/2 t plus 2. And so we can write it as a vector. We'll be talking about vectors in a couple of units. T, 1/2 t plus 2. Notice that my t's are squigglies, so that you don't mistake them with a plus. Or you can write it like t comma 1/2 t plus 2. Okay, well, what do we need these for? Well, we need this to deal with a system of equations, 3 by 3. So for example, I gave you the system 2x plus y plus z equals 5. I give you x minus y plus 2t equals 1, and you get x plus 2y minus z equals 4. I'm going to do it quickly. You can speed through the video if you want to do it on your own. So we have, I'm going to write this as let me manipulate it a little bit. So we have, let's see, I'm going to do x minus y, So remember I said put the 1 on top. So I'm going to do 1, negative 1, 2, 1, 1, 2, negative 1, 4, and then 2, 1, 1, 5. I said I'm going to do row 2 minus row 1 is my new row 2, and row 3 minus 2 times row 1 is my new row 3. And I have, let's see what I end up with. So I have 1, negative 1, 2, 1, I have 0, 3, negative 3, 3, and then I have 0, what do I have here? 3, negative 3, no, that's 3, sorry about that, and then the last one is 5 minus 4, which is 8. No, 5 minus negative 3. Let's see, did I make a mistake somewhere? I believe I made a mistake somewhere. Let's see where I made that mistake. 1, negative 1, 2, 1. 1, 2, negative 1, 4. 2, 1, 1, 5. R2 minus I1, R1, so that's positive 3. 0, 1, negative 3. 4 minus 1 is 3. 1, let's see. 1 minus negative 2, that's 3. This is negative 3. And then, oh, and that's positive 3. Sorry about that. Okay, well, I'm seeing what's going on here. So I continue and I say, okay, row 3 minus row 2 is my new row 3. And I'm doing this on purpose. You might ask, well, why aren't you eliminating the negative 1, Mr. Adler? Watch. I immediately recognize that I have 0, 3, negative 3, 3, 0, 0, 0, 0. So what's going on here? Actually, well, 0, 0, 0, I'm going to make another change. I'm going to do, oh yeah, so I get 0, 0, 0. What's going on here? How am I going to solve it? Well, what we have here is there's an infinite number of solutions. So because of 0, 0, 0, we have an infinite number of solutions. Because everything is true. Because 0 times something plus 0 plus anything plus 0 times anything equals 0. What are we going to do? Okay, well, we're going to do a general solution. First thing I'm going to do, is I'm going to continue to work on this a little bit. So let's start eliminating stuff out of here. First of all, I'm going to clean up row 2. So row 2 divided by 3 is my new row 2. And I'm asking you to be advanced math students. I'm going to add these two rows together after I do that. Then row 1 plus row 2 is going to be my new row 2. So let's see, what did we do here? So I knew this was 1, negative 1, 1, right? And then I added it together. So I have 1, 0, 1, 0, right? No, 2, sorry. 2. And then this row is 0, negative 1, 0, 1, negative 1, 1, 0, 0, 0, 0. Okay, so what should we do? Well, you know what? This is x plus z equals 2. So you know what? Let x equal t. That means we have t plus z equals 2. That means z equals t minus 2 minus t. Well, can you see that over there? I'm sorry. Sorry. Let me go over that again. I'm sorry. So I reduced this. Once again, I divided it out to 3, and then I added it to the first equation. So I had 1, 0, 1, 2, 0, 1, negative 1, 1, 0, 0, 0, 0. So I looked at the first, I said, you know what? Let's let the x be t. That means I had x plus z equals 2. So t plus z equals 2, z equals 2 minus t. Now I want to solve for, now find y. Well, I know this equation is y minus x equals 1. Y minus z equals 1, sorry. Y minus 2 minus t equals 1. Y minus 2 plus t equals 1. Y equals negative t minus 3. And that is the system. So therefore, for any t, I will get an answer to the system. Final answer, t sorry, this is plus 3. Yes, sorry about that. 3 minus t, 2 minus t. Any t you put in there gives you the correct answer. If t equals 0, you have 0, 3, 2. That is the solution up there. You can check that. Yeah, 0, 3, 2. 0, 3, 2. 0, 6, yeah. Yeah, 4 minus 3 is 1. 0, 3, 2. 6 minus 2 is 4. Every single answer works. Kind of cool. Let's move on. Now, we just looked at this last case where we had 0, 0, 0, 0, and so I had said to you, sorry, I need my eraser. I'm kind of excited because of the presidential elections. The idea is, how do we know if an equation has, like, what the type of solutions there are? So let's generalize. Let's generalize about ax plus b. Ax equals b. So I want to know, there's three possible outcomes. You can have a unique solution, you can have infinite solutions, or you can have no solutions at all. So what's the first issue? The first issue is if a equals 0. If a equals 0, we're either going to have an infinite or no solutions. So if a equals 0 and b equals 0, we have infinite solutions. Because it doesn't matter what x is. Like 0 times x, once again, 0 times x equals 0. Any x works in there. The problem is, if b does not equal 0, then we have no solution. We say there's no solution. So for example, like 0x equals 5. We can't get a solution out of that. Like, we're messed up. This is known as inconsistent, I think. Yeah, inconsistent. Inconsistent. Like, no solution. Parallel lines, which we like, but like, they don't meet ever. Now, what's the third case? If a does not equal 0, we have it's unique. If a does not equal 0, our solution is equal. So, for example, you might say, okay, like 5x equals 12. That's unique. So you say to Mr. Eller, what if b is 0? Well, this is unique, right? And then you might say, well, what happens if it's 0? Okay, that's fine. X equals 0. That's unique also. So so the idea is you're going to be given something like this. These are very basic when you understand it. And once you get Gaussian elimination, and you just work through it. So the question is 3x minus 2y minus 2z equals 1. 2x minus 4y plus z equals 4. And we have x plus y plus kz equals a. What you're going to be asked to do is you're going to be asked to manipulate this and find out for what values of k and a do we have infinite solutions, inconsistent solutions, and a unique solution. Now, you're going to do this on your own. I'm not going to do this for you because I want you to Actually, and it's in the book also. Or you know what? I'll do it. I know the video is getting a little long, but you know what? I think you like the sound of my voice. So let's go through this. 1, 1, K, A, 2, -4, 1, 4, 3, 2, -2, 1. What do you think the rules are? I'm going to get rid of that 2 and that 3. So, and maybe put the brackets over it. Now, here's the great thing. Let me tell you about it. You can actually put this in your graphing calculator. Go to Math, Matrices, Reduced Row. Then you're going to go back to Math, Matrix. Put a matrix in there. Put a 3-row by 4-column. Put all these numbers in. And then it'll reduce it for you. Unfortunately, what IB likes to do is I'll give you ones with K and A, so you can't use the technology. But in all these previous ones, you can use the technology to reduce your matrices, which is really important. Anyway, back to this. Row 2 minus row 1 is row 2. Row 2 minus 2 times the first row is going to be my new row 2. And row 3 minus 3 times row 1 is going to be my new row 3, okay? I don't touch the first row. 1, 1, K, A. You're in a higher level math because you're good at this stuff. Ready? 2 minus 2 is 0. -4 minus 2 is -6. 1 minus 2K is 1 minus 2K. 4 minus 2A is 4 minus 2A. Take a deep breath and use as much paper as you need and write nice and clear. Write in pencil at first if you get nervous. You can always go back. But I'm doing it in pen. Well, it's erasable. Next, 3 minus 3 is 0. 2 minus 3 is... -1. Sorry. -2 minus 3K is -2 minus 3K. No, sorry. -2 minus 3K and 1 minus 3A. Now, ready? I'm going to use, first of all, I'm going to negate all this. R3 divided by -1 is my new R3. I have to clean this up. Someone might say, you know what, Mr. Eilert, why don't you clean up the second row? You know what, maybe that's not a bad idea. That's not a bad idea. Let me clean up the second row also. Let me clean up the second row. Okay, 1, 1, KA. 0, 6, 2K minus 1, 2A minus 6, and then we use 0, 1, 3K plus 2, 3A minus 1. Okay, last thing. I'm gonna use this 1 to get rid of that 6. I can right? Because yeah, I'm gonna use that 1 to get rid of that 6. Or I can use this 1 to get, you know what? You know what? I'm sorry. I'm gonna use this. No, I can't use it because that 1 would put a 1 back here. And because there's a 0 here, sorry about that. I'm going to use the 1. So row 2 minus 6 times row 3 is my new row 2. And while we're at it, row 1 minus row 3 is my new row 1. But I'm a little interested in this. Let's see what happens. So I have, let's see, 1, 0. Let's see, K minus 3K plus 2 is negative 2K minus 2. A minus 3A minus 1 is 2A plus 1. Next, row 2 minus 6. 6 minus 6 is 0. I'm doing this on the side. because I need to do it on the side, and you can erase it, whatever. 2k minus 1 minus 6 times 3k plus 2 is 2k minus 1 minus 18k minus 12, which is negative 16k minus 13. And what's going over here? 2a minus 6 minus 6 times 3a minus 1. Do it on... Sorry, the computer went out. Do it on the side if you have to. I have to do it on the side. You know what? You're in the middle of exam. It's an hour and a half into the exam. My brain's not working anymore. Do not do it in your head. Do it on scrap paper. 2a minus 6 minus 18 plus 6. I made a mistake somewhere. I made a mistake somewhere. Where did I make the mistake? Ah, that's 4. That's a 4. That happens. But work through the whole thing. Do not, I knew I made a mistake. Just keep working. Do not stop. Work right to the end, and if you just make up your answer. You will still get your method points. You will not get an answer point, but you will still get all the method points. Okay, let's keep going. This is 4. Negative 16a minus 2. Sorry, there's a mistake here somewhere and I can't find it anyway. So it should be 2a minus 4 times 6 times 3a 6 plus 2. Sorry. So the idea, this is the correct answer is, I don't know what my mistake is. I don't want to shut the video off. The answer is, so the idea, no, I will come back. Sorry, this is correct. So it's negative 16a plus 2. And then the last row is, it's the same. 0, 1, 3k plus 2, and 3a plus 1. Now, we're done. And you say, well, we didn't figure how we figure this out. We just want to figure out what the a and k to get one of these things. And we're done here. This is what we're looking at. We're done here. And so the idea is, look at the equation. Negative 16k plus 13, like times z, equals negative 16a plus 2. So you say, if negative 16k plus 13 equals 0, so if k equals 13 over 16, right, and we take this negative 16a plus 2 instead of equal to 0, if a equals 1/8, so if a equals 1/8, then we have infinite. If a does not equal 1/8, we have no solutions. And last but not least, if k does not equal 13 over 16, we have unique. And that's the idea. So, I'm sorry, let me move this over. I apologize, guys. Sorry. Once again, we have this last step. It looks a little weird, but we want it, it's not fully reduced. So now we can kind of write and once again, erase this. Now we good. So we look, we say, okay, this thing times x equals this thing. And k and a are numbers, right? So the idea is, if this expression equals 0, and this equals 0, we have infinite. If this expression equals 0 and this does not equal 0, we have no solution. If this expression does not equal 0, we're good to go. We have a unique. That's it. So what I want you to do is try this problem. Literally like this. Sorry, it's literally like the second to last problem in the whole unit, but they made a mistake in the book. So I want you to try this one. It's like number 3, and it actually should be x plus y plus z equals 3, x plus ky plus 2z equals 4, and x minus y plus 3z equals b. And I want you to figure out the answers.